Welcome to Matt Explains Science. This is the third lesson in the General Chemistry course. Today we will be following on from the 3 states of matter lesson by looking at the physical and chemical properties of matter. So let's get started. So a substance can be identified by its properties. These properties can be physical or chemical. Physical properties can be observed and measured without changing the composition of the substance. However, a chemical property cannot be observed or measured without modifying the composition or identity of the substance. What then are examples of physical properties? The melting point and boiling point of any substance can be measured without changing its composition. A cube of ice can melt into water at just over 0 degrees Celsius and then will boil and turn into water vapor at 100 degrees. But water will still be present. We are only changing the physical appearance. Color can be observed easily enough with a naked eye or using a spectrophotometer to measure the spectral reflectance of a substance. Length, area or volume can be measured using geometry techniques. Mass can be calculated on a set of scales. And smell, well, you just use your nose. Now, on to some examples of chemical properties. To observe the chemical stability of a substance, we must test its reactivity in air or water. As for iron, it slowly reacts with moisture in the air to produce iron hydroxide, otherwise known as rust. Flammability is the test of how easily a substance can be set on fire. The preferred oxidation state of an element is the number of electrons an atom must lose or gain in order to form a chemical bond with another atom. And finally, the heat of combustion is the energy released when a substance undergoes complete combustion in the presence of oxygen. All of these properties can only be observed and measured once a chemical reaction has taken place, and often these reactions cannot be reversed. Some of the aforementioned properties can be measurable. What do we mean by measurable? Well, if quantifiable data can be obtained and compared against standard units of measure using measuring instruments, then a property is measurable. These properties can be either extensive or intensive. When measuring extensive properties, the value obtained will depend on the amount of matter being considered, and intensive properties are not dependent on the amount of matter. Right. Let's look a little closer at some extensive properties. So remembering that the value obtained from a measurement depends on the amount of matter being considered, we can state that extensive properties are additive. Basically, when you add them together, the values will increase. Examples: mass with units in kilograms, length with units in meters, volume with units in cubic meters, and energy with units in joules. This which is derived from the formula of newtons per meter. So all of these properties depend on the amount of matter, and they are all additive. If we take a ball of unknown substance with a mass of 1 gram and a volume of about 4.19 cubic centimeters, and then, for example, add 2 more balls of the same dimension, we can see that the overall length has increased from 2 to 6 centimeters. The mass has tripled and so too has the volume. All three of these properties depend on the amount of matter. Right, here we have some dynamite packed full of explosive energy. Using the TNT equivalent scale, I can tell you that 1 kilogram of TNT contains about 4,184 kilojoules of energy. Remembering that energy is additive, if we had another kilogram, then the energy doubles to 8,368 kilojoules. Now imagine, if you will, we had 1 ton of TNT, we would have 5.184 gigajoules of energy at our disposal. Finally, let's look at the intensive properties. We know that the measured values do not depend on the amount of matter. Therefore, these properties are not additive. Some more examples then. Temperature, pressure, and density. Let's start with density. If I had a box measuring 1 cubic meter and weighing 1 kilogram, its density would be mass divided by volume, which gives us 1 kilogram divided by 1 cubic meter, giving us a density of 1 kilogram per cubic meter, obviously. Now, if we had 3 cubes, then the mass would increase to 3 kilograms and the volume 3 cubic meters. However, if we look at the formula for density, we can see that the density is unchanged. Therefore, density is not additive. Now, if we consider a glass of water, the water contains 50 milliliters of water at about 15 degrees Celsius. If we were to add another 50 milliliters of liquid, also at 15 degrees Celsius, then what will the temperature be of the solution? Well, we would just get 100 milliliters of a solution and the temperature would remain at 15 degrees Celsius. So the temperature does not depend on the amount of matter. So there you have it. I hope you enjoyed this lesson, and thanks again for watching. Stay tuned for more content and please like and subscribe.